Okay, 4.5, solving rational equations and literal equations. So remember, rational equations. Rational equations means that there's an equal sign involved. So if it says the word equation, you are solving. If it says the word literal, literals involve variables of more than 2 or more. So for this problem, it says 10 over x equals 10 over 3x minus 1. So think of the last section. We were talking about combining complex fractions. So we're going to apply the rules that we did in complex fractions. We have a fraction equaling a fraction minus a whole number. Make the one a improper fraction. First step. Step 2, circle your denominators, because we want to find our LCD. In this instance, x, 3x, and 1, 3x happens to be our LCD. 3x is what I'm going to use to clear my fractions. So we're going to write 3x, 10 over x, equal sign, 3x, 10 over 3x, minus 3x, 1 over 1. Cancel out what they have in common. Well, here, x and x cancel each other out. 3x and 3x also cancel each other out, and nothing cancels out in the second part. We are left with 3 times 10 equaling 10, but that's what's left over, minus 3x times a 1. Do your math. So we're doing the product here, and that gives us 30 equaling 10 minus the product, which is 3x. So we're going to subtract the 10 to the left so we can isolate our variable. So we're left with 20 equals negative 3x. Then we're going to divide both sides by negative 3. So x equals negative 20 over 3. Now it says check your solution. So here's a hint for if you need to check your solution. Look at your denominators. And does your solution make it become 0? So if not, then keep it. If it does, that is called an extraneous solution, which means not possible. Next example. So it says 1 over a plus 4 minus 10 equals 5 over a plus 4. Again, make them improper fractions. I'm circling my denominators. So in this instance, our LCD is a plus 4. So prior to us solving this problem, let's determine what values a cannot be. Remember back when we were talking about domains. You look at your denominators. Well, a plus 4, if I said equal to 0, a cannot be negative 4. So if when we do our math, our result gives us an a answer equaling negative 4, then we have an extraneous solution, which means it's not possible. So since we know what our LCD is, this is what we're going to use to get rid of our fractions. We have a plus 4 over times 1 over a plus 4 minus a plus 4 times 10 over 1 equals a plus 4 times 5 over a plus 4. Cancel out your like terms. So a plus 4 and a plus 4 cancels here on the left. Nothing in the middle fraction. And a plus 4 and a plus 4 on the right side. Bring down what you have left over. So we have a value of 1 minus a plus 4 times the 10 equaling 5. Do the distributive property. So you have 1 minus a minus 4 still 10, equaling 5. Multiply in 1 minus, I'm going to write 10a minus a 40 equaling 5. We already have our minus sign change here. So we have 1 minus 10a minus 40 equaling 5. Combine your like terms. We have negative 10a minus 39 equals 5. Add the 39 over. So we get negative 10a equaling 44. Divide both sides by negative 10. So a is equal to negative 44 over 10, which are both even numbers. And that reduces to negative 22 over 5, which was not our negative 4. So that would be our answer. Next example. Okay, so in this problem, we have negative 8 over m plus 6 over 5 equaling 1 over m. What I'm going to do first is I'm going to make that negative sign go to the top value, just so it's easier to get rid of. We're going to circle our denominators. We have m, 5, and m. So in this instance, our LCD is 5m. Also, if I set this equal to 0, our domain says m cannot be 0. So if we have an answer of 0, that would not be our answer. We're going to use 5m to get rid of our fractions. So we have 5m negative 8 over m plus 5m 6 over 5 equaling 5m 1 over m. Cancel out your like terms. In this instance, the m's cancel, the 5 cancels, the m cancels. So we see 5 times negative 8, that's why I moved it up, plus m times a 6 equaling 5 times a 1. Do your product rules. So we have negative 40 plus 6m equaling 5. Combine like terms, so I'm going to add 40 to the right. We have 6m equals 45. Divide both sides by 6. So you have m equals 45 over 6. Now, 45 over 6, think of 45 as being 3 times 15. 6 is 3 times 2, because those are product factors, meaning the 3's cancel. So m is actually equivalent to 15 over 2, which was not our 0. So 15 over 2 would be our solution. On the next example, we have t minus 9 over t equaling 80 over t plus 9. So if I circle my denominators, treat them as independent pieces. So t cannot be 0 and t cannot be negative 9. So we know that if we have a 0 answer, we cannot keep it. If we have a negative 9, we cannot keep it. Since they both have t and t plus 9, our LCD for this problem is going to be t times t plus 9. Set up your fraction pieces. So t plus 9, t minus 9 over t equaling t plus 9, 80 over t plus 9. So now we're going to cancel out our common pieces. In this instance, t and t cancels out. T plus 9 and t plus 9 cancel. So we're left with t plus 9 times t minus 9. On the right side, we're left with t times 80. Now, when we look at this one here on the left, t plus 9 and t minus 9, these are conjugates, which are also part of your difference of squares. So if I do the expansion rule and multiply these together, you are left with t squared minus 81 equaling 80t. We need a factor. So in order to get this to factor, we need to have this side equal to 0. So we're going to subtract the 80t to the left and put it in decreasing power. So we have t squared minus 80t minus 81 equals 0. Now we need to come up with numbers that give us 81 that add to negative 80. Has to multiply the negative 81 and add a negative 80. So remember, the only thing that can give you that is 81 and 1. In order to get an 81 and negative 80, the 81 had to be negative, the 1 had to be positive. Split your t's. So opposites of the inside, so t is equivalent to positive 81, t is equivalent to negative 1. Well, if I plug in 81, it doesn't give me 0, does not give me 0. If I plug in negative 1, does not give you 0, does not give you 0. These are your two solutions. Next example. Okay, on this one, it has 6 over s minus 4 equaling negative 3 over 7s plus 5. Remember this negative sign, I'm going to give it to the numerator value, so it makes it easier. And when I look at my denominators, we know for our domains, s cannot be a value of 4, and s cannot be negative 5 over 7. And the reason I know that is if I take 7s plus 5, set equal to 0, and solve, you have 7s equals negative 5, s is equal to negative 5 over 7. So those are our values that we cannot be. We cannot be 4 or negative 5 sevenths. Since we have s minus 4 and 7s plus 5, our LCD is going to be s minus 4, 7s plus 5. Set up your fraction pieces. So all I did was set up my fraction pieces. The minus sign is joining the 3. When you get to this point, cancel out what they have in common. Well, in this instance, s minus 4 on the left, 7s plus 5 on the right. Bring down what's left over. So we see 5s plus 5 times the value of 6 equaling s minus 4 times the value of negative 3. You're going to apply the distributive property. So we have 42s plus 30 equals negative 3s plus 12 because a negative 4 and a negative makes it a positive. We're going to combine our like terms. So my 3s needs to cross the bridge. So we're leaving New Jersey and going to New York. We're crossing the bridge. We're adding it to the other side. So we have 45s plus 30 equaling 12. Again, we have to cross that bridge. So we're leaving New York, going to New Jersey. So it had to become negative there. So we have 45s equals, I had $12, but I spent 30 I didn't have. I'm short 18. Divide by 45. So we have s is equivalent to negative 18 over 45. Now remember your times tables and your factors. The number 18 happens to be 9 and 2. The number 45 is 9 and 5. So the 9s are canceling out, leaving you with s is equivalent to negative 2 over 5, which was not one of our actual s values here for our domain. So here's your solution. Next example. Says 6 over s minus 3 plus 2 over s minus 3 equals 2 plus 8 over s minus 3. So I make this an improper fraction and I circle my denominators. First thing, let's find what our domain is. So they all say s minus 3, so it means s cannot be a value of 3 because if I plug in a 3, I get a 0. 3 minus 3 is 0, and that's undefined. So we know that s minus 3 is what we cannot have for our solution. for this situation here, our LCD is going to be s minus 3. We're going to use that to get rid of our fraction pieces. So set up your pieces. Cancel out what they have in common. Well, s minus 3 cancels out in the first one, cancels out in the second one, nothing in the third, cancels out in last. Bring down what you have left over. We have a 6 plus a 2 equaling 2 times still s minus 3 plus an 8. Combine your like terms, so 6 plus 2 makes it an 8. Distribute 2s minus 6 plus 8. Again, combine your like terms on the right before doing any movement. Short 6, found 8, I have $2. Subtract the 2 over. 6 equals 2s, and if I divide by 2, it says s is equivalent to 3. I know for a fact that since s is equal to 3, it's making it 0, so this is going to be a D and E, does not exist, because this is an extraneous solution. So it's undefined. Next example. Okay, our first word problem. So first thing we do, let's look at our type of problem we have. It says Hannah can paint a room in 16 hours. Destiny can paint the same room in 20 hours. It says how long does it take for both of them to work together? So these are work problems. So in order to set up a work problem, it's going to be the individual over whatever quantity is. So in this instance, it's going to be the number of hours for this person, plus the second individual, individual 1, and then we have individual 2 over the number of hours that they take, equaling the together piece over the value we don't know, because we don't know how many hours. So we have our basic setup. So let's look at who we have. It says Hannah paints a room in 16 hours. So one room, because that's the type of thing they're doing. They're doing one room. She's doing one room in 16 hours. It says Destiny paints the same room. So it's one room. It takes her 20 hours. It says how long does it take them to paint the same room together? It's one room, but together is the unknown piece. That is our x value. So when we look at our thing, we have 1 over 16 plus 1 over 20 equals 1 over x. If I circle my denominators, we need to come up with our LCD. So let's come up with a common LCD. So let's look at our breakdown. 16 is 4 times 4, which is 4 squared. 20 is 4 and 5, so we have a 4 to the first and a 5, and then we have an x. So remember, LCD is one of every type, highest exponent. So I want the 4 squared, not the 4. I need the 5 and I need the x. So we have 4 squared times 5 times x, which means 16 times 5 times x, which is an 80. X is what our LCD is that we're using. So we're multiplying every single piece by 80x. So 80x times 1 over 16 plus 80x times 1 over 20 equals 80x times 1 over x. Because we already know the factors of 80, remember, we did it here, 16 times 5 gives us 80. So that means that 16 goes into 80 5 times. 20, they both share a 0, 20 and 80. So that means we know they're divisible by 10, but 2 also goes into 8, so they're divisible by 20. 20 goes into 80 4 times. And here your x's cancel out. So we have 5x times a 1 plus 4x times a 1 equals 80 times a 1. Do your product rule. So we have 5x plus 4x equals 80. Combine your like terms, which means 9x equals 80. Divide 80 by 9, and we get x equals 80 over 9. Depending on how your homework system or whatever software you're using wants the result, you can put it in as 80 over 9 or as a decimal value. So 80 divided by 9 gives us 8.89. I went 2 decimal places, so I would always leave them as a fraction answer, but that's just me. If we look at the next problem, it's another word problem, just doing another work problem, just different things. In this one it says, Fred can mow a lawn in 120 minutes. Bullwinkle can mow the same lawn in 80 minutes. It says, how long does it take for them to mow the lawn together? Again, so Fred is an individual, and I really don't care it's a Fred, as he's mowing a lawn. This is what he's doing. He's mowing a lawn. It takes him 120 minutes. So one lawn, 120 minutes. Plus Bullwinkle, don't care that's Bullwinkle, but I notice it's the same lawn and it takes him 80 minutes. So the same lawn, 80 minutes. Again, they want to know, I don't care that it's Fred and Bullwinkle together. They're mowing the lawn together. That's the time frame. So one lawn, X as what we're looking for. Again, let's look at our denominators. So we see 120, 80, X. We need to come up with our LCD. So again, 120, 80, and X. So 120, we have, you can do the fact they both have factors of 10, so that's 10 and 12. That's 10 and 8. We're trying to figure out which ones they're both go into. So here the 12 becomes 4 and 3. That 8 is 4 and 2. And let's circle what we have in common. They both share a 10, because I want it. They both share a 4, because I want it. This one has a 3, I need it. This one has a 2, I need it. And then your X. So if I do our multiplication, 10 times 4 is 40. 40 times my 6 is 240. 240 with an X is our LCD in this instance. So that's what's going to be on the outside of our fractions. So we have 240x over 120 plus 240x 1 over 80 equaling 240x 1 over x. So we cancel out our common pieces. Well, 240 happens to be double 120, so that becomes a 2. Zeros cancel out here, and 8 goes into 24. That is 3 times, so this reduces to a 3. And your x's cancel out. So we're left with 2x times a 1 plus 3x times a 1 equals 240 times a 1. Do your product rule. So we have 2x plus 3x equals 240. Combine your like terms. That gives you 5x equaling 240. And then divide by 5. So 240 divided by 5 gives us 48. So 48 minutes. If they were to mow the lawn together, it would cost them 48 minutes only. Next example. At the beginning of the notes, I talked about literal equations, and I said literal equations have variables, more than 2 variables. Here we have an R, an S, and a T. There's more than 2 variables. If I circle my denominators, my LCD is going to be R, S, T, one of each. And that's what I'm going to use to get rid of my fractions. So R, S, T, 5 over R, plus R, S, T, 3 over S. Equals RST 3 over T. I set them up. And here's the thing that we need to pay attention to. It's asking us to solve for the letter R. So in order to get to R by itself, you need to get rid of your fractions. That's why we're using our LCD to get rid of them. So here, R's cancel, S's cancel, T's cancel. So we're left with ST times the number 5 plus RT times the number 3 equaling RS times the 3. So we see 5ST plus 3RT equals 3RS. So at this point, we notice that there's R's in this piece and R's in the right side. Remember, we're solving for R, so we want to get our R's together. So I'm going to subtract the 3RT to the right. So we become 5ST equaling 3RS minus 3RT. When we get to here, since you can't visualize R equals, in this instance, think of an imaginary line or a mirror. You can always do this, and just transpose the mirror image. So it says positive 3RS, positive 3RS, negative 3T, negative 3RT equals positive 5ST, so 5ST. I didn't change anything, I just did a mirror image of it. Okay, since we want the R by itself, factor out what they have in common. I want the R out is what I want. So the R had to come out, and we have 3S minus 3T. Yes, I know that they both have a 3 in common, but remember, you're solving for the letter R equals 5ST. And since I want R by itself, I'm just dividing by the parentheses that I have left over to both sides. 3S minus 3T. So your final answer is going to be R is equivalent to 5ST over the parentheses 3S minus 3T. Close your parentheses. Make sure you put parentheses around the denominators front and back end, because if you're entering into any software, the calculator will read it, or whatever software system, as 5ST divided by 3S minus 3T if you do not put parentheses at the beginning and end. Next example, it says, first thing, solve the rational expression for the letter D, is what they want us to find. So we have P over D plus B equals G over D. Yes, there's a lot of variables involved in this problem. So we're looking at our denominators is what I'm looking at. D plus B and D. So our LCD in this instance is going to be the letter D times D plus B. Do not distribute. Do not distribute here. This is what we're using so we can cancel out our fractions. So we have D plus B times P over D plus B equaling D plus B times G over D. Don't distribute here. So here we're going to cancel out what they have in common. In this instance, D plus B, D and D. We are left with D times the letter P equals D plus B times the letter G. Because remember, we're solving for D, so first thing we gotta do, we gotta distribute. So we have dP equals dG plus BG. We want our D's together, so I'm going to subtract dG to the left. So we become dP minus dG equals BG. Remember, we're solving for the letter D, so we need to isolate the D out. D comes out, and you're left with P minus G equaling BG. D by itself means you're dividing by P minus G to both sides. So your final answer will be D is equivalent to BG divided by P minus G.